Copper pipe has been one of the most commonly used materials for water supply needs over the last few decades. I'm Ben, a forensic engineer at Nederveld. Today we are discussing copper pipe and how it should be evaluated and handled for product examination. Copper pipe has been the industry standard for potable water supply, heating, and cooling applications for many decades due to its durability and reliability. Whether being used for water supply applications or hydronic heating and cooling systems, the main function of copper pipe is to deliver fluid without leaking. Copper pipe should be installed with sufficient support to prevent side loading and bending moments, while also allowing for thermal expansion and contraction. Surfaces must be prepped prior to soldering, which includes cleaning, deburring, and reaming. The installer should use the correct solder for the present conditions and application. To get a fully soldered joint, it is critical not to overheat or underheat the pipes. There's an ASTM standard that must be followed. ProPress is a newer system of joining and branching copper pipe that uses an integral gasket to create the seal inside a fitting or joint. Tooling is then used to crimp the fitting onto sections of pipe. It is a faster and more efficient joining method to perform on wet systems, and it eliminates issues that come with the use of solder, flux, and heat. As with all matters involving products, documentation of part numbers, age, date of installation, and who installed the copper pipes should be recorded. The condition and orientation of the copper pipes should be well documented with photographs prior to removal for collection into evidence. Additionally, any records of prior maintenance or repairs in proximity to the product should be documented. The most common failure points in copper pipes are freeze-related rupture, corrosion, and improper installation. An installation-related issue could be a solder joint surface that is not properly prepared, or where the installer fails to solder the complete circumference of the pipe. Then we have abuse, external forces, and overpressurization. Some examples include when a copper pipe is struck by an impact, is subjected to a side load, or is overpressurized, possibly from a freeze failure. An example of age, wear, and maintenance would be an old copper pipe that is compromised by corrosion. Manufacturing or material issues could include a discontinuity or void in the material from processing. Erosion is another potential failure mode and is an issue related to flow velocity and time. While examining a copper pipe product, we look for fracture presentation, wear marks, corrosion, discoloration, deformation, and leaks. Age, installation date, maintenance records, usage patterns, and environment are all factors that should be considered while examining a copper pipe failure. If the part arrives undocumented or after significant mishandling, we may have insufficient information to determine the cause of failure. So remember, proper documentation and collection of evidence is important. Feel free to check out our other videos in our collection to learn more.